How's everyone today? You ready? Okay, I'll answer questions over the homework in just a moment. I want to talk about a week from today is our first exam. And if you look at our schedule, bless you. If you look at our schedule, then today we're actually supposed to be doing Introduction to Functions 3.6. We're not going to get to 3.6, so we're going to finish 5.1 today. On Tuesday, we are going to review for the exam, and then on Thursday, we're going to have the exam. So we're going to go ahead and just push 3.6 till later, all right? But the plan is to stay on track to have the exam on Thursday. So what will happen is I'll finish up 5.1. Then on Tuesday, I will have a review, okay? You need to be here for that review. And I'll probably pass out something and have you work on it in class. And then I will provide answers to it and things like that, all right? So be here Tuesday. Sometimes students get shocked because they're like, oh, it's just a review and he records it and I'll just watch it and whatever. And then they find out that I hand out the review and I don't do anything. I just go around and help people, and then they're like, what happened? You know, there's no video. Where's your video? And there was no video. So don't skip out on Tuesday unless you have a good reason to. Now, questions over homework? No? Now, numbers 1 through 6 should have had you scratching your head a little bit because it asks you to like match the properties and stuff, and that's my fault. When I don't know why, but when I looked at it, it didn't like cross my mind that we'd only talked about 2 properties. So how is it that you were supposed to match them to the rest? So I am sorry, but hold off on 1 through 6 for now. By the end of today, you should be able to go back and hopefully address those, okay? So sorry about the headache if I gave you one. Now, if there are no questions, we're going to proceed and start with what we walked away with last time. Is that okay? You all ready? And then we're going to pick up some new stuff today. So last class, the major results were, first of all, anytime we have x raised to a negative power, we don't like negatives, right? Well, it's just a convention. We just don't like to leave negative exponents. It's just the way we do math. It's not incorrect, but it's just, I guess, easier on the eyes to not have negative exponents. The math gods don't like them. So we write 1 over that to a positive power, right? That's one of the main things we did last class. And then we did this rule, and it was called the product rule. It said that if we have the same base, so 2 bases that are the same, and we have different powers, so we're trying to multiply these things together, as long as they had the same base, what happens? What do you do with those exponents n and m? You add them, right? You add them. So we're going to go ahead and add those 2 together, and we would get x to a new power n plus m. This is known as the product rule. It just comes from the idea that, remember, this whole section is about exponents, right? Exponents. What we have is a product. Product means multiplication. We have a product of 2 exponents with the same base. If that happens, we add the exponents. We're happy. That's where we kind of ended class last time, right? Okay. Now, the new rule for today, and where we're going to start, is what is called, well, let me write it out first. Let's say you have x to a power, okay? How many bases do you see there? Just one base, x, right? And then you decide that that power that you have on x, you want to take the whole thing, just for the hell of it, you want to raise it to a power again. So you have a single base to a power, all of that to a power again. The result of this is that base, that single base, raised to the n times m instead of n plus m like the other one. Now they call this the power to power rule. And they call it that. Why do you think they call it that? It's a power raised to a power, right? It's a power of x raised to a new power. So that's the rule. The way that you can kind of see the difference between the two rules we have there, the product and the power to power, is that with the product, don't you have two bases? Same thing, but there's two of them, and then you have powers on each one. Where on the power to power rule, you have a single base, then a power, and then another power raising that whole thing up. So let's just take a look at how this rule would work. Okay, let's start with this as an example. What if we have 2 to the third to the negative 2? So the main question, and this is what we're going to be getting to as this class progresses, is you have to see which rule applies to this. So if I look at this, what I see is a single base, 2, right? A single base with a power, 3, and then that raised to another power. So I've got a power to a power, don't I? So I'm going to apply that third rule there, the power to power rule. That rule tells me I should take whatever's in the base, which is 2, raise it to the 3 times negative 2. What's 3 times negative 2? Negative 6. 2 to the negative 6. But we don't like negative exponents, right? So using the rule from last class and what you did on your homework, that should be 1 over 2 to the 6. And 2 to the 6 is 2 times 2 times 2 times 2 times 2 times 2, which is 64. A lot of times students will just break out their calculator for that. But I'll show you another way you can do 2 to the 6. Just maybe this would work. If you can visualize in your head, if you can visualize this, 6 2's lined up, what are the first 2's? First 3 2's multiply to be? What's 2 times 2 times 2? That's 8. What are the second group multiply to be? 8. What's 8 times 8? 64. Maybe you can see that in your head. Maybe not. It's okay. It doesn't matter. But that's just one way you can break down exponents. Let me erase that. I was about to erase that. That wasn't going to work, was it? Losing it. All right, let's try something a little more robust. How about negative 2 to the second to the negative 2. I'm just trying to mess you up with all these signs. So do we have a single base? Yes? What is it? Negative 2. Now it's the whole thing. It's the whole negative 2 because I have it in parentheses, right? So the power positive 2 is acting on the entire negative 2. So if you want, you can kind of squint your eyes. That negative 2 is like our x, right? That's being raised to an n, which is being raised to an m. So this is kind of that formula again, isn't it? So what I'm going to do is I'm going to say this is equal to whatever that base is, raised to the 2 times negative 2. Now, is that correct for me to write it like that? What's wrong? That negative right there, I'm saying, yeah, that I'll work with. But is this right this way? Is this power going to be, is it going to be acting on the 2, or is it going to be acting on negative 2 if I write it like this? That's right. I need the parentheses around the base. Because if you leave it off, then the power is only acting on the 2. Remember we talked about that negative? It's important if the parentheses are there or not. Since my entire base was the -2, I need to put it back into parentheses. Now let's multiply the exponents. 2 times -2 is -4. So I have -2 raised to -4. And we don't like negative exponents, so I rewrite that as 1 over -2, yeah, parentheses, -2 to the +4. So all I did there was use the property that says if we have a negative power on something, we write 1 over that something to the positive power. Now it's time to do -2 to the 4th, which means what? -2 times 4? No. Do I need to flip or something? No, you only flip things around or move things if it's a negative up here. So all this means is -2 times -2 times -2 times -2, which is +16. So 1 over 16. There you go. What do you think? It's all right? Ready for the next rule? Okay. What's going to get challenging here, if it gets challenging for you, what it's probably going to be is the fact that the problems towards the end are going to be a combination of all the different rules. Like that problem was only power to power. Later on, we'll have 3 or 4 of the rules mixed into one problem. You have to make sure you're doing them all correctly. So, all right, next rule. Here's the way this works. Let's say that we have something like a base x, and we decide that we're going to multiply it times something different. Now, x times y, you can't put those together, right? Right? X and y, you can't put them together. They just would sit there next to each other, x times y. But let's say I want to take the x and the y, and when I want to raise it to some power n. What this rule says is that you can break the x and y, you can free it from the parentheses, as long as you take the power up here, and you put it on both of these. Now, when we say put it on there, it's not distribution because you're not multiplying. Okay, I'm not going to take n and multiply it through. I'm taking the n and I'm applying that exponent to each the x and the y. So it'll turn out looking like this. It's the x, whatever was there, to that power, times the y to that power. Do y'all see that? No more parentheses, but they both get raised to the n. Now this rule is called the, was I writing in? I was writing in red, okay. This is called the, what we have inside the parentheses is multiplication, don't we? The fancy word for multiplication, or another fancy word, is product, right? So what we have there is a product. And what's happening to that product? What am I doing to that product? Yes, with that n, right? That n is a power, isn't it? So I'm taking a product and I'm applying a power to a product. So we call this the product to power rule. If you have a product, x times y, to a power, then you use this rule. Examples. We'll start out with something somewhat basic. 4x, negative 4x, raised to the third power. Now, why is that not the rule we did just before this? Yeah, you have negative 4 times x. So we have a base, right? I mean, you could call negative 4x the base, right? But we don't have a power and then another power, right? What we do have is a product, though. Product means multiplication. Negative 4 times x, so two things being multiplied just like in the formula, x times y. And then from there, a power on both of them. So to free the negative 4x from the parentheses, we must apply the third power to both. Third power here, third power here. Now be careful. How do you apply a third power to negative 4? Like, what do I need to write? I have to be careful with this. There you go. Parentheses, negative 4, then the third power. Is that it? Times the x now to third power. So they both get that third power. Now that's the property. Okay, that's the property being done. The next thing I need to do is actually figure out if I can simplify this anymore. So can you simplify negative 4 to the third? What does that mean, negative 4 to the third? Negative 4 times negative 4 times negative 4. 3 negatives multiplied is a negative answer, right? So we should get negative 64? Negative 64. And then x to the third, I can't do anything to, right? So I'm done. Negative 64x cubed. You don't have to put the dot between those, okay? It's implied multiplication. All right. We turn the screws now. Have you ever heard that expression before, turn the screws? Yeah? Oh. If an x is in the exponent too, oh, well then we're not in college algebra anymore. Now that's in calculus, you deal with that. When your variable appears both in the base and the exponent, it's something pretty unique. It doesn't happen often, but it does. It is something you'd have to deal with. Just if you're not going to go past college algebra, you'll never see that in your life. Yeah. Yeah, there's all sorts of possibilities that could happen. Unfortunately, we're going to not see that one. Okay, so again, turning the screws. Have you all heard that before? Turn the screws. What I mean by that is it's going to start getting harder here. I think it comes from torture devices, like medieval torture devices. Like they used to like put people's heads in like a vice, and then they would, yeah, pull their body apart or something like that. And what they would do is they'd be like, give your allegiance to the king or whatever it is, or, become a Christian or whatever. You want to be a Christian? No. Turn the screw, clamp their head a little tighter, and then they either eventually do what they're told or they die or whatever. So turn the screw. So that's what we're going to do now. We're going to just make this a little bit more unpleasant, okay? So here comes another one. How about negative 3 x squared y to the negative 1, all of that to the negative 3. I know you like it. I know you just don't want to act like you do and have people have different opinion of you. But I'm trying to please you here by giving you something fun. Now, I'm not making these problems up. These are all like things out of the book, so I'm not just like trying to torture you. Wow. There's a lot going on here, isn't there? Yeah, there's multiple rules happening here. Do you see that we have multiplication, though? I'm going to put 2 dots in there. Y'all see the 2 dots? These multiplications separate 3 distinct things. You could have actually looked at it both ways, but if there's an implied multiplication, we're gonna look at it and we're gonna separate there. Now, just to get some language, we're on the same page here. I have 3 things being multiplied, right? Each one of these is called a factor. It's kind of like when you take the number 10. 10 is the same as 5 times 2, right? 5 times 2, each one of these is a factor of 10. But so when you hear me say factor, all I'm saying is that it's one of these guys that are being, oh, that's a girl, being multiplied in there. That's, okay? So we have 3 factors instead of how many are in the formula? In our formula number 4, we had 2, x and y, right? What do you think happens if you have 3? What does your instinct tell you would happen? I mean, up there we had 2, the n went to both. If we have 3, what do you think will happen? The n goes to all 3. And if you have 4, the n goes to all 4. And if you have 20, the n goes to all 20. So we have 3 distinct factors here. I'm gonna highlight them. I asked my other class if they were if they thought this was a little too childish to be using the highlighter like this. I'm sorry if it offends you. I'm not trying to. But it helps some people, so that's what I'm gonna do. So I'm putting little arrows there. Remember, that's not distribution. I'm just telling myself I'm going to apply this power to each of these 3 distinct factors. Here they come. Here's the removal of the parentheses. So I have to take that first yellow -3, and I need to do what with it? Put it in parentheses and raise it to the -3rd power. Times, so there's my yellow guy. Now I need to take the next one, which is x squared, and raise it to the 3rd, right? Now the only way to write that down where it makes sense is to also throw a parentheses around the x squared and then put your 3rd up there. -3, thank you. And then last is the y to the -1, and I'm going to raise that to the -3. There we go. So now what are we looking at? Each of those 3 things turned into those. What rule, if any, do we have for these? This is power to power, right, on the second one? And the third one's power to power? And then the first one, -3 to the -3, is just that first one where if you have a negative, you drop it down. Because -3 is a number, so I'll be able to just drop it down. So let me try and do all these in the next line. The first one becomes 1 over what? -3 in parentheses cubed, right? And then the next one becomes x to the -6. We got that by multiplying those 2 powers together, 2 times 3, or 2 times -3, give us -6. And then the last one here, y to the 3rd, and we got that by multiplying -1 times -3, gave us +3. Now, 1 over, what's -3 to the 3rd power? -27. Times, bless you. What is x to the -6? Well, we don't like the negative, do we? 1 over x to the +6, right? And then y to the 3rd, I'm happy with. But because I have a bunch of fractions in front of it, I'm going to write it over a 1. Because isn't anything over 1 itself? And this just might help you see how we're going to get to the next line. We're going to go multiplication now, straight across top, straight across the bottom, and basically just combine everything together. So the top, when you multiply 1 times y cubed, you get y cubed. And on the bottom, -27 x to the 6, just put them next to each other, and we have arrived. Are there any questions? Okay, your turn. I'm going to give you a couple of problems. Turn the lights on, give you about 10 minutes, see if you can work these out, okay? And then we're going to go on. We still have the quotient rule, the quotient to power rule, and then one other, sign change rule. 2 down, 3 to go. But let's make sure that you can do this on your own. So please try these. I'll call this example 1. I'm on page 339, but I'm kind of making up the problems. I'm just looking at what they have here to give me some sort of idea of what I want to do. How about -7 to the -1 to the second? Yes. Oh, okay, yes, thank you. You'll get credit for that. Give me a second, though. Remind me again after I write these problems down. 4 to the 4x to the -2 to the -3. And then the big daddy. How about -3 x to the 4th y squared z to the -5, all of this to the 4th. Now, take a second to write this down. I want to talk about example 3 after you've written it down. There's 2 things I want you to notice about that. What's your last name? Anna? Or Anna? Okay, here comes the sign-in sheet. Okay, let me talk about that third one. 2 things. First of all, how many distinct factors do you have in that problem? Okay, they are the -3, that's 1, x to the 4th, that's the other one, y squared, third one, z to the -5 is this one. Now, the next thing I want to ask you is I'd like for you to write down on the side, somewhere on the scratch top corner of your paper, I'd like you to just write the number 2. Next to it, I want you to write z. And then I want you to ask yourself if you can tell the difference between your 2 and your z. Do you write your 2's and z's different? Or do they look pretty much the same? That's going to depend on you. My advice is that if your 2's look like your z's, to do this. It's called striking your z. Anytime you write a z, you draw a line through it, through the middle. It's called striking it. And what that does, it helps you distinguish your z's from your 2's. All right? So just a little thing to pick up on. You don't want to be doing a problem and then think a 2 is a z or a z is a 2 and then everything's off, right? Okay, go for it. I'll put the answers on the board here in a second. I'm going to pause my video and walk around and answer any questions that you might have. But I am going to go through this last one. So on this last one, we have quite a bit going on. Like I said, it's multiplication between 4 separate factors. Now, I'm going to kind of get rid of the highlighter, and I'm just going to kind of draw some lines here. Those are my 4 factors, 1, 2, 3, 4. So the rule says that I can split this up, get rid of the parentheses if I take each one of those factors and raise it to that power on the outside. So I take my -3, I want to raise it to the 4th. But I have to throw it in parentheses, especially because it's a negative. Then I'm going to take the x to the 4th, and I'm going to raise it to the 4th. So again, I need parentheses around it so I can raise it. Power to power. Next one is a y squared, and I'm going to raise it to the 4th power. And finally, z to the -5, raise it to the 4th power. So now I've got all my factors split up. Each one of them is about to get a 4 exponent applied to it. What is negative 3 to the 4th power? 81. That's negative 3 times negative 3, 4 times, right? You get an 81. Now the second one, which is x to the 4th, we have power to power rule. We multiply those powers. X to the 16. Next one, power to power again. Multiply 2 times 4, get 8. And last one, power to power again. Multiply negative 20. Now every one of these is okay except the last one. 81 is 81, x 16th, we're happy. Y to the 8th, we're happy. Z to the negative power, we're not happy. So that gets dropped down, right? And then everything else is up in the top. So it becomes the 81, x to the 16, y to the 8th over z to the 20. That's it. Okay. You ready for the next property? Here it comes. So the next property says, and this would be property, what are we calling this, 5? Where are we? The first property? It didn't really have a name. Yeah, it doesn't really have a name. That's just a property of exponents. So it's not really a rule. If you want, you can call it, we can make up a name. You want to make up a name? Drop negative exponent, something like that. I mean, I don't know what you want to call it. Negative exponent gets dropped, right? Drops down underneath the 1. Yes.
Example 3 that we did, why again are we dividing it by the z?
Example 3, why are we dividing it? Okay, because this last term over here, or this last factor right here, becomes a 1 over z to the 20th, right? And then in front of it is a y to the 8th, which we say over 1. The x to the 16th, we say over 1. The 81, we say over 1. And then when you go across, that make sense? Okay. All right, so this was now the fifth property. The 5th property, it's called the quotient to power. So I'll write the name of it first, then I'll write it down. Quotient to power. What is a quotient in mathematics? Do you all know what a quotient is? No? We have 4 operations in math, 4 standard ones, right? Addition, subtraction, multiplication, and division. Quotient is division, all right? That's another word for division. So this is division to a power. So if you have x divided by y raised to a power, then something happens. And what I'm going to do is underneath this, I'm going to write down our second property. Do you remember? Well, you have it probably written down. It's your second property. Wait a minute. Was it second or third? Hold on. No, this one. Hold on. It's not the second one. 4th one? Is it? Our numbers are all screwed up. Our 4th. Yeah, the 4th one right there, the product to power, that's the one I'm referring to. Okay, I'm going to write that underneath this one. 4th one, product to power. This was x to the n, y to the n. And basically what we did was we saw a product inside of parentheses. We applied the power to each one. This time, instead of seeing a product in the parentheses, what do we see? A quotient, which is the opposite of multiplication or product. So as you might expect, I don't know if this seems natural to you, you can drop the parentheses as long as you apply the power to both the top and the bottom. So if you have a quotient to a power, take the power and apply it to both the top and the bottom, the numerator and denominator. I just showed you that other one just so you could see it's somewhat related to that one. Quotient to power. Shall we try? Couple? Okay. How about this? What is 2 over x to the third power? Isn't that a quotient to a power? So you just do the top to the power and then the bottom to the power. So apply the 3 to both. What's 2 to the third power? 8. And then x to the third power is just x to the third. And that's it. There's nothing else we can do with that. That seemed pretty natural, just apply the power on top and bottom? You're welcome. I turned the light back on. Is it too glary? It is? It depends on where you're sitting. If you're right in the center, it's pretty bad glare. All right, well, this is kind of a mess, isn't it? So when you look at this, I want you to just, first of all, notice that you have a quotient, right? I mean, I agree. You've got a bunch of other stuff happening too, but if you just kind of squint your eyes and just take a step back, it is something divided by something to a power, isn't it? It is. So let's just apply the rule that we just got, top and bottom, right? That power is going to go to the top and the power is going to go to the bottom. So the way I write this needs to be the top's going to get the power and the bottom is going to get the power, right? Whatever it is, the 3 goes to both. The exponent of 3 goes to both the top and bottom. But what was in the top? What was in the numerator? Negative 3x to the negative 2, right? So that's my entire numerator now. But now I've got to raise that whole thing to the 3. And then on the bottom, what's there? Y to the 4th. Does everyone see that what I've done is got rid of the big parenthesis by letting that 3 act on both the top and bottom separately? Okay, now take a look at the top. Isn't this just a what? Oh, I'm sorry, problem number 4. I didn't know I thought you were saying I messed up some 4. This is the product to power, right? You have 2 things being multiplied, product to power. And on the bottom, it's just power to power. So you got 2 rules happening here. So I'm going to kind of stress that on the top we have a product by putting a dot between the negative 3 and the x. The product to power rule says that I take the negative 3, I raise it to the third. I take whatever else is there, the x to the negative 2, and I raise it to the third. On the bottom denominator, I just use the power to power rule. And what do I do with the 3 and 4? Multiply them. 3 times 4 is 12. So we get y to the 12th. Whoa. All right. See if we can work that. Top left, what's negative 3 to the third power? Negative 27, right? That's negative 3 times negative 3 times negative 3. Now the x to the negative 2 to the third is power to power rule. So that's really x to the negative 6. And then on the bottom, y to the 12th. Nothing changed on the bottom, right? So am I happy with that answer? Can I box it? Well, I mean, I could, but it's not all the way there because of this, x to the negative 6. So drop it, right? Drop it. Now on a test, I mean, let's say on a test, I usually grade every problem on a 10-point scale, meaning I look at it and I say, look, the most student can get is 10 here, the least is 0. If I look at that, you get to that, you box it, you're going to get 9 out of 10. Okay, so you do get partial credit in this class, you know, as long as I can follow your work, make sense out of it. Then if I can find your little errors, then you get, you know, you get something, which is better than like a Scantron, true, you know, type test where it's all or nothing. Is that okay to write it that way? I dropped the x to the negative 6 down, but I put the y in front of the x. Is that okay? It actually doesn't matter. Now, normally people like to write the x before the y. Why do they do that? Because alphabetically, wait, w, x, y, yeah, so x goes, that's why they do it. But other than that, there's no reason, right? The things that we would have to worry about are things like this. If you have 5x, you usually write 5x, right? You don't write x5. But it's not technically wrong. It's just not normal. That's not normal. This is okay either way. Alrighty. We shall proceed. Now the next rule. These rules are fun. I wasn't going to say fun. I was going to say something else. The next rule is the quotient rule. Quotient rule. Quotient rule says that if I have x to a power over x to another power, that the answer is. Now, how is this different than the rule we just had? We have different powers, right? In fact, the fraction I have doesn't have the same base, right? Don't those both have the same base? We've had something with the same base before. It was actually our second property. It looked like this. We had same base to the n times same base to the m. Remember that one? And that was your homework. You added them, didn't you? So whenever you have two bases that are the same and you multiply, you add, so subtraction will occur here. It's kind of weird, but that's what happens. I'll show you why if you really want to know, but it's n minus m. Now it is important to notice that it's the n minus the m. It's the one on top, the numerator's power, minus the denominator's. It's not the other way around. That matters, right? Because if I say 5 minus 2, is that the same as 2 minus 5? No. So subtraction order matters is what I meant to say. In math, we call that the commutative property. Commutative. If you can flip it and it stays the same, it's called commutative. Subtraction is not commutative. But those are fancy words. Who cares, right? Is this okay, or do you want to know why? I mean, let me ask you this. If I wrote this, isn't that property we just had a second ago? Property 2, same base. Wouldn't you add the exponents? And if you add these, isn't that the same as n minus m? But wait a minute. Don't we not like exponents to be negative? So drop it down, and what does it become? That right there. Isn't it? It becomes that. So all this is really just pushing the x to the m back up and then using the rule we had before. But we make it its own rule, all right? It's called the quotient rule. So here's an example of the quotient rule in action. 5 to the 12th over 5 to the 9th. So if you were to get on your calculator right now and try and figure out the top, it would be, 5 times 5 times 5 times 5, 12 times, right? It'd be a big number. Then divide that by 5 times 5, 9 times. It's a big number. Or you can use this rule that says, since they have the same base, right? Now that's important. The 5s have to be the same. All you have to do is write the 5, subtract, so 12 minus 9. What's 12 minus 9? 3. 5 to the third power, 125. Get over here. We'll do another one. And then after I do this one, I think we're getting pretty close to me. Well, we have one more rule. Then after that, I think I can give you something a little more challenging. What would this be? Negative 5 x to the negative 10 over x to the negative 8. The things that you want to start to see here is, like, you don't have power to power, right? You don't have a base to a power and then all that to a power. You don't have product to a power, so you don't have parentheses and then all that to a power. What you do have, though, if you look at it, is you've got this right here. That is x to a power over x to a power, so same base, right? Same base. So I can look at the numerator up here, negative 10 as being my n, and then the negative 8 as being my m. I always try and overstress n and m, because when I was in graduate school, I had a professor from India, and he always said n, he would say n, yen, what did he do? He said n was n, and m was n. So they both just sounded exactly the same to me. He'd be, n and n, and I'm like, okay, I guess I'll guess. I'll guess on that. So n and m, all right? No, because he didn't distinguish. He would say n and n, and they both meant, I mean, they meant different things, but he said them exactly the same. I'm saying this particular professor had trouble with n and m. What? I didn't hear. Yeah, we should probably leave that one alone. Okay, x to the, okay, so what am I going to do here? Be careful. I'm going to subtract one of them from the other one. Which one do I? Top one first, right? Negative 10. And then subtract. I will, hold on. Yep, I will. I need to subtract what, though? Negative 8. I think I know what you're thinking over there already. So what is negative 10 minus negative 8? That's negative 10 plus 8, isn't it? And that's negative 5 x to the negative 2. But we don't like negatives. So we write negative 5 and we drop the x to negative 2 down as an x to the positive 2. What did the negative 5 do in this problem? It just came along for the ride, right? It just kind of was there to just give you something else to look at. Now, I believe, what was your name again? Katie. I think Katie was going to say something that I agree with maybe we should have done first. Were you going to say, why don't we take the negative and drop it down, make it positive? So that x to the negative 10 would drop down? Y'all agree with that? To start the whole problem over, x to negative 10, drop it down. But what do? We haven't talked about this, is why I didn't bring it up. What do you do if you have an x to a negative number and it's already down? You bring it up. Okay, so that's a new sort of property that we need to write down and make sure we're clear with. But I'm going to do it on this problem. I'm going to take the negative 5. I'm going to bring the x to negative 8 up. It becomes an x to the positive 8. Then on the bottom, the x to the negative 10 dropped down, became an x to the positive 10. These are separate problems here. I mean, separate work. Now I have to do the same thing. It's negative 5 x to the 8 minus 10. So I'm still going to have to do that subtraction. 8 take away 10. What's 8 take away 10? Negative 2. So you see we're still in the same place now? So the answer, I think, is yes, Katie. Either way will work. And that's one of the things I actually liked about math when I was learning it, even though I told you I didn't like it too much for a long time. Is the one thing I did like is that as long as you don't break a rule, it's good, okay? I mean, as long as you don't break a rule, things should work out. I relate it to someone trying to take a trip to somewhere. They're trying to get from point A to point B, right? In math, we're trying to get from the problem to the answer usually. If you're really good at math and you know all the rules and you're comfortable, this is usually the path you take, the shortest one. But if you're not too comfortable, what happens is that you do something that may work and you know you're going around, whoa, wait a minute, hold on. And maybe you're going in circles and maybe it's taking you forever to get to this problem, but you're not breaking any rules, then you should still be able to achieve the goal as long as you don't break a rule. If you break a rule, you're no longer on this planet, okay? You can't be on this map anymore if you break a rule. The only way to get back to point B if you break a rule is to accidentally break a rule back and it undoes what you broke earlier. You know what I'm saying? Like you have to accidentally stumble back into the right answer. So, you know, we have shortest ways. I don't care which way you go as long as you don't violate any of the rules. All right. All right. Yeah, so let me write that property down. We're not going to have a name for this, but we saw earlier, this is from earlier, so you don't need to write this. We saw that if it was on the top, we dropped it down on the bottom, became positive. But this is the rule. If we have it on the bottom and it's negative, then it pushes to the top and becomes positive. Now there is actually a line under this in a 1, but we don't normally write it. But I'll put it here just to kind of stress to you that, you know, it is technically being pushed up to the numerator. No, I'm not sure. Yeah, there's not really a name. Okay, and the last one, last rule. So what was the last one was the 5th one, right? This one I didn't name it, but can we call it the 6th rule? Is that okay? It's 7? Dang. Okay, and then the 8th. The 8th I'll put over here. This is called the sign change rule. Here's what it says. It's basically what we just did, but now written as a rule. Where does x to the negative n go? It drops to the bottom. Where does x to the negative m go? To the top. So you could look at this rule as this. If you want to change the sign on the exponent, you just have to flip it. It has to go up or down depending on where it started. All right. I think we should now try and do something out of the exercises. And since I said I kind of feel good about you all in here, let's see how you do on these two. Or I'll do one, you do one. How about that? No, you try that one. I think I'm done. You try that. And then if you can, after that one, try this one, and good luck. 5. I'll put your homework assignment here in a second. I did want to tell you something before I forget this. I will repeat this on Tuesday, but maybe to give you some peace of mind over the weekend. I will allow you a cheat sheet on the test. Okay, but this cheat sheet can only contain formulas. All right, so you can have all these rules written down. You do not have to memorize all these rules for this test. So part of what you'll want to do is, as you're going through your homework, maybe, write down the things that you had to refer to. Like if you had to go back and look at something, you probably want to put that on your cheat sheet. So just keep that in mind. It'll be, I'll have a limit. You can have 1 page front and back. I mean, if you want to bring a note card, you can, but you can't bring a spiral full of notes. You know what I'm saying? Just 1 page front and back. And it cannot have any worked out problems on it. So you can't go print off my notes and then zoom them down and make a bunch of copies, and it's no work problems, just formulas. You can write down steps, anything in words. Okay, if you want to do this, then this. You can write that all down, but you just can't have problems worked out. Okay, let's see how you do on this. Hold on, that's not right. Don't ignore what I just put up there. These are the answers in blue. Okay, your homework assignment's there also.